Hello everyone, this is Mr. McMillan, and to start out this instructional video, because it's going to be important, I want to show you something on the Desmos calculator. This is specifically the one that you will see on the SOL test next semester, or this semester, whichever semester you're taking it. This is the Virginia Standards of Learning version. Okay, so today we're going to be talking about ratios, proportions, and scale factors. And when we do that, we need to be able to simplify fractions. Normally we can just find the greatest common factors, the least common denominators, all that stuff, and then divide each of them, the numerator and the denominator, by those to get the simplified fraction. But in Desmos, it will do it for you. So let's say, for example, that we had 3 divided by 6. Okay, and you'll see that in your results screen here, it gives you 0.5. 0.5 as your answer for 3/6. Now, if you look here, there's this little button, there's this little thing here. If you click this, it takes the fraction and it makes it into the simplified form. Okay, so for example, if we do 25 over 40, it gives us our decimal. We click this button here and it gives us 5 over 8. Okay, if you have one that does not simplify, such as 12 over 7, it will give you the decimal representation. If you click that button, it will give you 12 over 7. Okay, so this will be utilized. I won't show it on here, but this is a good tool to utilize in order to simplify fractions the fastest. All right, so without further, so we're going to be talking about similar polygons and scale factors. Similar figures are two figures that have the same shape but not necessarily the same size. Okay, same shape, not necessarily the same size. For two polygons to be similar polygons, the following must be true. Number one, corresponding angles must be congruent. And number two, corresponding side lengths must have the same ratio. So if you take these side lengths and you divide them, they have to all have the same ratio based on their corresponding sides. We call this the scale factor. Okay, the scale factor is the common ratio, common size ratio that you have in your figures. So I do want to make a point here. Congruent figures, every congruent figure is similar. Okay, every congruent figure is similar to all its other congruent figures. Okay, because they would have a ratio of 1, they would have a scale factor of 1. Okay, similar polygons do not have to be congruent though. They can be double the size, triple the size, half the size, whatever. Okay, now like congruent figures, similar figures can be compared based on their corresponding parts. When listing these in a similarity statement, we still list the vertices in the same order based on corresponding parts. Now, symbolically, we write, and we just use a tilde instead of the equal with a tilde over it, instead of the congruence, okay? And the reason we use that, this is the congruence is everything's equal. Here, everything's not, right? So you can think of it like that. You don't have the equals for similar because not everything will be equal. So let's look at this diagram here. So we have corresponding angles here and corresponding sides. We want to find the scale factor and we want to write some similarity statements. So let's look at our diagram here. We can see, to start out with, our corresponding angles we see that we have markings in our diagram. Remember, the same number of markings means those angles are congruent. So we can say that angle K is congruent to angle N. Angle B is congruent to angle X. And angle R is congruent to angle C. All right, now we need to look at our corresponding sides. So our corresponding sides, if we look here, we can see that RK and CN are corresponding sides. Now, since these are going to be similar figures, we need to write them in a ratio. So that's why I have RK over CN. Okay. Now, if you do that, RK over CN, you'll have 20 over 10, which is 2. So let's look here. We also see that RB would be similar to CX, or proportional rather. So we have 24 over 12, which is equal to 2. And then finally, we see KB and NX. Which would be 12 over 6, which would be 2. Now notice when we calculated the ratios that all of these had the exact same ratio. That's important. So since we have a set of congruent angles, or 3 pairs of congruent angles as well as 3 sets of proportional sides, that means that these are similar and they have a scale factor of 2. Okay, and there is a way we write this. We say that RK over CN is equal to RB over CX, which is equal to KB over NX. Basically, we're just saying that they have the exact same ratio. Now, you could have done it the other way, and you could have had it here like this. 10 over 20, 6 over 12, 12 over 24. In that case, your scale factor would have been 1/2, okay, if you flip it the other way, which you can do. What matters is that you're consistent, okay? You have to be consistent. So, similarity statements, we might write triangle KBR is similar to triangle NXC. We may write triangle RBK is similar to triangle CXN. We may write triangle BKR is similar to triangle XNC. So on and so forth. Just like congruent statements, there are 6 different ways to write these similarity statements, and they still have to be listed in the same order based on the corresponding parts. Now, when given similar figures, we may also be asked to determine the length of a missing side of a figure. To do so, we must set up a proportion to determine the missing value. When doing so, it is important to be consistent when writing your proportion. Let's look at the following diagram to see why. So in this one, it wants us to find the length of a missing side, given that triangle ABC is similar to triangle DEF. Well, we are given 2 sets of sides here. Now we need to make sure that we are consistent with writing our proportion. And what it means by that is if we start with one triangle and go to the next, then we need to start back at the other triangle for the second part of the proportion. So for instance, if you take X here, X is FD, and you look at your similarity statement, FD is in the first and third spots. It has to be similar, or it has to be proportional to AC because it's in the same locations. So FD has to be over AC. Then, since we started with this triangle, we have to go back to this triangle. So our other side is ED, and ED is in the first and second spots. AB are in the first and second spots here. Now you could also write this as AC over FD equals AB over ED. They're the same exact thing, just they're inverted. It'll give you the same answer. So I'm going to use this one here. FD is X, AC is 27, ED is 10, and 15 is AB. Cross multiplying, because we have a proportion here, we have 15x equals 270. Divide both sides by 15, and you get x equals, I can't do that in my head right now, equals 18. Okay. Now, let's look at why this would not work if you did it another way. So let's say you did x over 27, and you have 10, and instead of doing 10 over 15, you did 15 over 10. So you did small over big and then big over small. The reason this doesn't work is because the ratios, the proportions, while they might work here, are not going to work whenever you get the similarity statement. So if you solve this, let's just solve this real quick just to show you. So we have 10x equals 15 times 27 divided by 10, and you get x is 40.5. Now, this is the smaller triangle. This is the bigger triangle. We know this is the smaller triangle because ED is less than AB. X should not be greater than AC. So that does not work. Okay, so make sure that you pay attention to how you're setting up your proportions. Okay. All right. All right, so we're going to look at a couple of these numbers 1 through 6. You'll notice they're not triangles, but the exact same thing applies to them, whether they are congruent or not. So we need to make sure that we are paying attention to that regardless. Now, the first thing I like to check for on any of these when determining whether the figures are similar is to look for the congruent angles or not. Are the angles congruent? If the angles aren't congruent, you don't even have to go any further because you know the sides won't work. Okay, so all angles have to be congruent. Now, if we look here, we're only given the one angle here, 105, but based on that, we can say that all those angles would be congruent. Okay, so let's look at the side ratios then. We only have two different sets of sides because we have two pairs of congruent sides for each of these. And we see that we have 10 and 25 and 12 and 30. So we're going to divide each of these separately. So we have 10 over 25. 10 over 25, if you plug that in to your to calculator and simplify it, you end up with 2 over 5. Then let's do the same thing for 12 over 30. Remember that these two have to match exactly for these to be similar. 12 over 30. If you divide both of these by 6, you will get 2 over 5. This checks out. So these are similar, and they have a scale factor of either 2/5 or 5/2, depending on which one you did. So let's look at number 2. Number 2, we're going to do the exact same thing. Check your angles first, see if they're congruent or not. So you have your angles here. You have 6, 6, 4, 4, or sorry, you have 4 right angles and 4 right angles, so the angles are good. Now let's check the ratios of the sides. We have 4 over 8. 4 over 8 will simplify to 1/2. Then we have to take 6 over 16. 6 over 16 both can be divided by 2, which will give us 3 over 8. These are not equal, so these are not similar. Then let's look at number 3. Number 3, we see two different angle measures, but you'll notice that they are on different angles. One is here in the obtuse area and one is in the acute area. If you take this angle, you know that this one would have to be 60 degrees as well because they are same side interior, same thing here. So let's check our ratios. Again, we only have two ratios to compare. So we have 7 over 21, which is 1/3, and we have 8 over 24, which is also 1/3. So these are similar, and their scale factor is 1/3 or 3, depending on how you did this. Okay. All right. Let's look at the next couple. We are going to do we're going to do 3 of these. Yes, 3 of these, and then we're going to, I'm going to give you the rest of them to do on your own for practice. Okay, that's going to be your assignment for today. So let's look at 7, 8, and 9. 7, 8, and 9. Okay, so number 7. Number 7, it wants us to find the missing length indicated by a question mark. The triangles in each given pair are similar, and it gives us a similarity statement. Use your similarity statement to figure out how you need to set up your proportions. Okay, so in here, I'm going to start out with the smaller triangle to start with, and I'm going to start out with UV. So that's going to be my first bit there. So UV is in the first and second spots. ED is in the first and second spots there. So that needs to be in that part of the proportion. Then we have equals. Our other side is VW. VW is in the second and third spots. DC is in the second and third spots. So that's what we're going to put in that ratio. Now we just plug in our values and solve. UV is 16. ED is X. It says question mark, but it's X. VW is 20. And DC is 65. Notice how I switched between the triangles. Small over big, small over big. You could do it the other way, big over small. Just make sure you're consistent and you switch between the triangles. Solving this proportion, we're going to cross multiply. 20 times X gives us 20X. 16 times 65 gives us 1040. Divide both sides by 20. And you get that X is equal to 52. Number 8, I'm going to go ahead and put an X next to the question mark. I'm going to start with this triangle here on the left, the smaller one. So we have BG. BG is in the first and second spots. BC is in the first and second spots, so BG over BC. Then we have HB, which is in the first and third spots. And first and third spots, we have BD here. BG is 14. BC is X. HB is 22. And BD is 33. Now we have our proportion set up. Now we're going to cross multiply and solve. X times 22 is 22X. 33 times 14 is 462. Divide both sides by 22, and you get that X equals 21. All right. And finally, number 9. Numbers 15 through 22 are the exact same. Instead of just an X, you'll have like an X plus 4 or 3x minus 2 or whatever. So let's look at number 9. Now number 9 is significantly more complicated, you can see that. But we still have two separate triangles here, even though it's a little bit confusing with this extra line in here. So we have a smaller triangle here, QLK. And we have a larger triangle, QSR. Okay, so the smaller side and the larger side match up on each respective side. So we have QR as our unknown. So I'm going to go ahead and label QR as my starting point. So QR is in the first and third. If we look here, QR and QK would be the ones that match up. Notice that they're on the same side, the large over small. Then we can pick from the other two large and small sides. So we can either pick these two or these two. It's not going to matter whatsoever. So I'm going to pick QL and QS. So QS has to go on top because it is the large one. We started with the large here, so we have to start with the large again. Over QL. QR is X. QK is 8. QS is 42. And QL is 6. Then we cross multiply. And we get 6x equals 42 times 8, which is 336. Divide both sides by 6, and you get that x equals 56. Okay. So now what I want you to do, I want you to do numbers 4, 5, 6, and then 10 through 22. Do as many of those as you can. There will be an answer key video posted later that goes over these as well. Okay. If you have any questions, please feel free to email me, especially if you're having difficulties with the content. You need to make sure that I'm aware of that so that I can help you out. This includes attending Zoom sessions if need be, because for a lot of people, in-person instruction or seeing it done live is a lot better than watching a video. Okay, so let me know if you have any difficulties. I hope this video helped. I know this one was rather long, and I apologize for that, but there was a lot to cover today. So thanks, guys, and I will see you in the next video. And this is going to be what we discuss in this video, as well as do some practice problems related to this. So similar to triangle congruence, there are certain shortcuts that can be used to determine triangle similarity from a few pieces of information. There are 4 postulates, and this really should be 3 because, again, there's one thing on here that we don't need to use in this class. And the 3 postulates that we are going to use are these first 3 that we talk about. Okay, I do want you to know that the other one exists, but for the purposes of this class, we don't really use it all that much. So, oh, by the way, the assignment that I'm going to be posting will be IXL P.7. I will be sending out usernames, passwords, all that stuff, as well as another list of IXLs that you guys can do for credit for other assignments and things like that. So the first postulate that we're going to talk about is angle-angle. And as you can tell by the name angle-angle, it only requires 2 pairs of angles. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. So for instance, in this diagram here, these are similar because they have 2 pairs of congruent angles. Now the reason you only need 2 pairs of congruent angles in a triangle is because if you have 2 pairs of congruent angles, then all you need to do for the third side or third angle is you'll have them 4 there. So if you have 2 angles in a triangle that are congruent, then the third one automatically becomes congruent because these 2 are the same. you're subtracting the same values from 180 for both triangles, which means these two would be the same. So that's why you only need 2. So in this case, we had angle K being congruent to angle Y, and we had angle J being congruent to angle X. Okay, so that's angle. 2 pairs of congruent angles, and that's all you need. Next up is side, side, side. Just like the name implies, it involves 3 sides. If the 3 pairs of corresponding sides of 2 triangles are proportional, and the word proportional means that they have the same ratio or scale factor, then the triangles are similar. Okay, so you're going to need to divide the sides with one another to see if their ratios all match up. So in this diagram here, AB matches up with FG. So we would write if AB over FG equals, then we do our second set of sides. So here we can use AC over FH, which is equal to BC over GH. So if you were doing this in a problem, you would take 12 over 9 and see if it's equal to 19.6 over 14.7 and see if that's equal to 16 over 12. Okay, so you would divide each of those, and if they give you the same ratio, the same fraction, then you would have side, side, side similarity. And then the last one we are going to be using in this class is side angle side. And just like in congruence, when we talked about side angle side, what we're doing is having 1 pair of congruent angles and 2 proportional pairs of sides. Okay, so in our diagram here, we have 2 sides that have an angle in between them. So in this case, we need XZ over MP to be equal to XY over MN. And then our angle that's congruent is angle X is congruent to angle M. So your ratios that you would do in your problem, you would have 16 over 13 and see if it would equal 32 over 26. Okay. The other one that we're not going to be using, but I do want you to know, is hypotenuse leg. And it's the exact same thing. You're going to take the ratios of the hypotenuses and the ratios of the legs and see if they're the same. Okay. All right, so let's look at some examples. So let's look at number 1. For all of these problems, the whole 18 problems, and this is what your assignment tomorrow is going to be on. So it's fine if you just watch the video and understand how to determine each type of congruence or similarity that we deal with. So all of these want us to state if the triangles are similar. If so, state how you know they're similar and complete the given similarity statement. So let's look at the first one. Now, if you look in the first one, we see that we have no sides labeled. We don't have any numbers on the sides, so we can't use the sides. But we do have 2 angles, right? So that rules out side angle side and side side side, but we can see if we can use angle angle. So let's look here. We need 2 pairs of congruent angles. So let's look at angle V. Angle V is 69 degrees. Do we have a 69-degree angle in the other triangle? The answer is yes. Angle G is there. So angle V is congruent to angle G. And angle W has a 59-degree angle. Is 59 in the other triangle? Yes, it is. Angle W is congruent to angle F. We have 2 pairs of congruent angles. So we can say that They are similar by angle angle. And then what it wants us to do is complete the similarity statement. So it has triangle WVU, and the exact same way we did congruent statements, we're going to list them in the exact same order. So W corresponds with F, V corresponds with G, and U corresponds with H. Now let's look at number 2. Number 2, we see that we have a pair of congruent angles, and the pair of congruent angles is between two sides. Now, the important thing to note here is just because the angle's between two pairs of sides does not mean that you have side angle side similarity. It's not like congruence where you can just look at it and go, okay, yes, those are side angle side. What you need to do is you need to make sure that your ratios are the same. So let's look at that. We have a pair of congruent angles, that's good. Now we need to look at our ratios. The way I do the ratios here is I take the smallest side from one of the triangles, which is 40, and then I take the smallest side from the other triangle and compare those. Those two would have to correspond. So 40 over 72. And if you simplify 40 over 72, if you watched yesterday's video, you'll know you can use Desmos to do that fairly easily. Then you will get 40 over 72 simplifies to 5 over 9. That's just one ratio though. What we need to do is we need to see if the other one is equal to this. So we take 59 over 108. And this doesn't actually simplify. If you plug this into Desmos or your calculator or whatever else, it doesn't actually simplify. 5/9 is not equal to 59 over 108. Since the sides are not proportional, we can say that this is not similar. And if they're not similar, you don't do the similarity statement. Next up, number 3. Number 3, we see that we have one pair of congruent angles at 87 degrees, and that's at angles G and angle LME. Now, here's the thing. These two triangles overlap one another. So we have a small triangle lying on top of a bigger triangle. So what you need to do is, just like when we were doing congruence postulates, you need to look and see if you have a shared angle, okay? So unlike where we look for shared sides, we're still going to be looking for vertical angles and similarity, but we're going to be looking for shared angles as well, okay? So if we look here, we'll see that we have angle E as our shared angle. So that means that we have two pairs of congruent angles. Angle E is a shared angle, and G is congruent to angle LME. So that means they're similar by A. And our similarity statement, we have triangle EFG. So we would have E is itself, F corresponds with L, and G corresponds with M. Number 4, we have triangle FED. Triangle FED, well, we need to see if they're similar first. I'm getting ahead of myself here. So we have angle F here on both ends. These are vertical angles, so they're congruent. And we have two pairs of sides. Now we need to make sure those sides are proportional though. So let's look at this. We have 12 is our smallest side here. So we're going to look at our other triangle, and 20 is our smallest side there. If you reduce these, you can divide both of those by 4, do it in the calculator, whichever. Then you get 3 over 5. Now let's do the other ratio. So we have 18 over 30. 18 over 30, you can divide both of them by 6, and that gives you 3 over 5 as well. That checks out. So these are similar by SAS. And we would say FED corresponds to FRS. Number 5. Number 5 is a little bit of a unique case. We can immediately see that we have a pair of vertical angles here at point P. So that's one pair of the congruent angles. We see that we don't have any sides, but we do see that we have some parallel lines. Now here's where our parallel lines and transversals from previous units comes in. If we extend these parallel lines, okay, both QD and CR become transversals. So if we look at CR, for instance, I'm going to extend this, and we look at angles C and angles R. Angles C and R are on the opposite side of the transversal, so they're alternate. And we see that they're both in the interior of these two parallel lines. So since they are opposite inside, they are alternate interior angles, and alternate interior angles are congruent. So you have angle R is congruent to angle C because of alternate interior angles. You could also say that Q is congruent to angle D for the same exact reason. So we have two pairs of congruent angles, so that means these are similar by AA. So triangle PQR is similar to triangle PDC. We're going to cover one more example in this, and you can try the rest of the problems that aren't worked out. I will have an upload for that paper copy of the answer key that you can check your answers with. I'm not going to post a video explaining all of those. We are going to look at number 8. So number 8. Now, number 8, you're missing some side lengths here from some of the triangles. But since these are overlapping triangles, we can figure out what the missing sides are. So let's look at our small first. We don't have all two sides for the small ones yet. However, we do know that EK is 24, and we know that ED is 64. Well, if the whole thing is 64 and one part is 24, we can say that KD is equal to 64 minus 24, which is 40. So we know that KD is 40. And on this side, we know what these two parts are, but we don't know what the whole thing is. So we need to take and find the whole thing here. Well, the whole thing, we take the two parts, add them together, and we get 30 plus 18, which is 48. So we have two pairs of sides that we can use. We have these sides here for the small triangle and these sides here for the large triangle. And you'll notice that we have angle D, which is a shared angle. So that counts for our one angle that we need. So here we can say we're going to do our ratios. So we're going to take 40. 40 corresponds to 64. 40 over 64, if you take 4 or 8 and divide each one of those, you get 40 divided by 8, which is 5. 64 divided by 8 is just 8. Then we're going to do our other ratio. So we have 30 over 48. You can divide both of those by 8, or not 8, I'm sorry, by 6, and you get 5/8 as well. These are both the same ratio. That means they are similar by side angle side. So triangle DEF would correspond. D is itself, K, and then J. And that does it for this video, guys. I will have an answer key uploaded for the other ones if you want to attempt those, or you can just look over them and check them out. Okay. Make sure that you do the IXL assignment that I'm going to post tomorrow. I will have those passwords given to you through email before the end of the day that I post these. Thanks, guys, and I hope this video helped. If you need any assistance or anything like that, make sure to email me so that I can help you out. All right. See you in the next video.